Okay, so I've got a list of questions here that were submitted early on. So I'm going to direct the first one to you, Dominic. The question is with regards to star bags and star cages, advantages and disadvantages. What is a star cage and bag? Is it something worth considering, basically?
Yeah, so we've seen a few of those coming on the market recently. Star bags are in cages are an attempt to try to make your normal filter bags have a greater surface area. So kind of like extending, increasing the size of the filter without actually making it bigger. Kind of taking inspiration from pleated filters and from cartridge collectors that pleat the fabric over so you get more surface area. Um, Unfortunately, it's one of those things you see somebody come up with a proprietary design, tell you everything is magic, and then sell it for quite an inflated price, right? One thing we always point to when people introduce proprietary designs like that, we usually come around and we ask, well, if it's really so good, why is it that they're the only ones selling it? And that's kind of how it seems with these star bags and star filters. There's not much really conclusive proof that they're any better, especially to justify the increased costs. And there already exists something which is pleated filter elements that go into a baghouse, which kind of fills this role already. So we wouldn't necessarily recommend using either the star bags themselves or certainly not installing the star cages with normal bags because it would not provide the needed support for the bags when you're pulsing them. But it kind of it's a good reference point, Matt, for like all these kinds of things that come up that are supposedly the magic bullet, but then nobody can ever answer why they're the only ones that make it, and nobody else in the marketplace has copied them. Everybody copied the pulse jet after it was invented, I believe, by Micropole in the late 60s. Within 10 years, every single major bag house manufacturer started making pulse jet bag houses. So things that are new, that innovation happens, but then it's quickly implemented across. And star bags just haven't really proved that yet in the marketplace.
Great answer. All right, I'm going to handle the next question here, which is how to size a collector for a new application. So, very broad question that we hear a lot. I'm going to point you to our website where there's and maybe Andy, you can put a link in the chat box here to where they can download our dust collection system sizing guide. So the short answer to a very long, process is basically you figure out your airflow, your CFM requirements. You come up with a square footage of your filter media based on an air to cloth ratio. You determine the correct configuration of collector based on the dust type, and there's a lot of other factors. So I'll point you to the website where you can download our guide, which gives you the basic steps to do that. Now, if you want to do that in-house, also, your other option, of course, is to just send us an email to info@baghouse.com or any of us on here, and we'll help you do that for your system. So send us the info you do have. One of our dust collection experts will take a look at it and help you make sure you get the correct sizing. Let's see. Other question here. What is the max temperature for that bags can sustain these days? So I'll give this one to Scott. It doesn't say on the question here what specific process or temp the person is looking for, but Scott, when you get a request for filter bags,
Yeah.
how do you approach that?
Yeah, in the chat box, we can put the guide that we have as well that kind of goes over some of the different temperature variants that we see. The short answer, again, it kind of depends. We have different fabric types or medias that we'll call that are able to handle or withstand different temperature variations. For example, polyester is usually good until about 240 to 265. After that, we have aramid bags. It's a type of media that's commonly known as Nomex as well. That's good up to like 400. Bags that are good up to 500 degrees would be like glass, P84 bags, things like that. So each bag has a different temperature rating. If you're unsure what the media is, you can always send us a picture of them. We can generally tell pretty well by just looking at a picture. And obviously, we don't want to sell you a bag that has a high temperature application that will honestly burst up in flames, right? So we want to make sure that we get you the right bag. So when you do submit a request, a lot of times we'll ask for that. If you don't know the type of bag that it is, what's the temperature range that we're dealing with, and we can make a suggestion based off that. And then, yeah, how often we have to change them out, that's, kind of based off usage. How aggressively sized is our system, for example. If we have to account for like any moisture issues, there's a whole line of different things that we look at by making that type of suggestion. But generally, if you're changing out your bags every 2 to 3 months, you're probably not getting as much life out of them as what you probably should be able to put it that way. So if you feel as if you're changing things out too often, let us know. We can talk about it and we can look at some different things to try to improve your operation there. But generally, 6 months to a year, some people even get 2 to 3 years out of their bags, just kind of some, general parameters that we see today.
Very good. Yeah. So it depends on your application, what temperature you're required. Scott or any of us can help you determine the correct filter that will withstand that temperature. The hottest of the hot, there are actually metal filters out there for extremely specialized applications. Very uncommon. If you're pulling in an inlet temp that's, 550 degrees Fahrenheit or something on that, you probably be better served looking at bleed air or some kind of a cooling process to get your filter temp below the threshold of a regular commercially available filter bag rather than go look at some highly unique filter, ceramic filters elements or something like that. So mostly what we deal with up to about 500 F, right, Scott? And then, we use bleed air where required to cool and get stuff below that. Next question here. This one was from the chat. As a full service provider like you, what are the biggest challenges that you face in the process of manufacturing? Do you outsource? So two questions there, really. So I'll just give you kind of a broad answer and then a more specific answer. We do outsource some things. Obviously, we can't make everything for every project. Some of the things that we will offer, will come from our suppliers. I will say we're very tightly integrated with our supply chain and our manufacturing partners. So our whole purpose and our whole approach is to be a single source OEM full service provider to you as a customer. If that means that we have to go contract something, a specialty product, then we will do that. But at the end of the day, we're responsible and accountable for how your project ends up and what we offer you. So I hope I answered the question there. I will add one other thing. Almost everything that we provide is manufactured in the US. There's some things like electronics, raw materials, components that do come from overseas, like Dominick said. But, baghouses, ductwork, equipment, that stuff is all being made in the US. We are in compliance with contracts, federal government contracts, which have, buy USA clauses, all that kind of stuff. So, we're based in the US and almost everything that we sell is coming from the US. Okay, let me go back to the list here. So here's another topic for you, Dominick, having to do with continuous emissions monitoring. Where did the questions go? Yeah, continuous dust emission monitoring. So that's just more of a topic. What would you say to someone, I guess, an end user who's trying to figure out do they need emissions monitoring? Like, why would you need it, and how would we approach it as a vendor to spec out a project?
Yeah. So I would say emissions monitoring, just so we all know, we're talking about trying to actually monitor how much dust is going out the exhaust of the baghouse, right? Out the exhaust stack. So there's really two reasons you'd monitor it. One is for emissions compliance, right? Making sure you're in compliance with your air permits. And the other reason would be for maintenance or operational reasons, right? The same equipment can accomplish both things at once. You might choose it just for one reason, but really you can do it for both things at the same time. Kind of the way the industry has been going for the most part is to triboelectric emissions monitoring. So in older plants, you had opacity monitors where they have the mirror with the laser thing. those still exist in some places because they're written into existing air permits and things like that. But really, the triboelectric detection systems are just far superior, far more accurate and sensitive. So those have really replaced those in almost all other instances, except kind of where the industry regulations are slow to adapt. But all new applications certainly using the triboelectric ones. That's just a probe that goes in and detects down to 0.000002 grains per standard cubic foot. A ridiculously small amount of dust it can detect. So if you're using it for emissions, sometimes people get scared and they think that if they have that, then their regulatory agency is going to be very strict with them and make them have this absolutely low monitoring level and things like that. It's really not what we see. Usually, the air permitting agency is going to set the levels of whatever they set it. And then if you don't have anything that it tells you in real time what's leaking, they're probably going to be more aggressive with you because they want to give themselves more protection to prevent you from having an overage, maybe from a leaking filter or something or an upset condition. When they find out that you have the broken bag detector installed, they actually will a lot of times be more moderate in what they demand of you because now they know that you're accurately recording what's actually going out, and they don't have to just rely on modeling to figure out and estimate how much pollution is leaving your facility, right? So it can be really useful for that. Even if that's not a interest to you, just having them for maintenance and operation is absolutely wonderful. And we recommend them to everybody because the ability to know in real time how the filters are operating, right? Really, the only guide you have is the differential pressure and then looking and seeing if dust is coming out the exhaust. Um, it's kind of hard. We have to make a lot of inferences and stuff to figure out how things are working. When you have the broken bag detector to supplement that, it's amazing because you can diagnose things so quickly. But even just a practical example, if you have in your bag house something gets sucked up, it cuts a hole in one of your bags. Even if you have a really big bag house, 1,000 bags, one small little hole, quarter-inch size, is gonna, depending on how much dust you suck up, make just literally tons of dust blow through before you realize it's going out the stack. Now you have to shut down. You have to send guys in the top of your dust collector, brush out the dust collector. You might have to shovel out the material, clean out the ductwork down to the fan, all kinds of hours and hours wasted doing remediation work, right? And then you also might blow your air permit, have to shut down for that reason, all kinds of bad things. That simple probe that's in there will tell you when that hole is just barely beginning to form to the point where it's completely invisible to the naked eye, the amount of dust coming out. So knowing it's leaking at 1 o'clock on a Tuesday, you might even have enough advance warning to get your team together and say, look, in the next couple hours, this would be a problem, or tomorrow, let's shut down in 4 hours. We have some time. Go in there, find the bag that's leaking, and we can fix it before it causes all these other problems. Even if it's just a big bag house, you can use them also to identify the row of bags that has leaking filter in it, so you don't have to do quite so much chasing down of leaks. So there's really a lot of benefits to them, and they also can help you forecast when your filters will fail. So there's a set when they need to be changed, and you can be more accurate and have a little bit more warning than just going off the DP. So we recommend they go on everything. When you're quoting a system with us, we'll usually include it as a additional option. And there's a lot of different outputs and things like that we can do. So we're always, we need a little bit more information to finalize it, but it's something we recommend for just about everybody in all six circumstances, whether it's just for emissions, just for maintenance, or it's for both things.
Very good. I'm going to add to that too. So emissions monitoring is very important. As Dominic said, it will save you time and money and headaches and pay for itself, even if you don't have a mandate from EH&S or something like that to do it. There's all kinds of sensors and monitors out there that can be connected nowadays. Emissions monitors are one, hopper level sensors, fan, rotor sensors, airflow sensors, really anything that you can think of can be measured with a gauge with an output that can then be collected and used for your PM, maintenance, predictive maintenance. When do the filters need to be changed? When has something gone wrong? there's really a whole world of possibilities now over and above simply alarm, having an alarm which triggers when you have a broken bag, which in itself is super valuable. But there's other stuff that we're now offering, which will include connectivity, options. You can beam all this info up to the cloud, use AI to evaluate when you are going to have to change your fan bearings or belts, for example, based on the vibration data of your fan. You can have airflow monitors so you can see when something's going wrong somewhere in your ductwork, emissions monitoring, differential pressure, all that stuff now can be beamed into your control station or your cloud-based dashboard, and you can use it for predictive maintenance. There's a very strong ROI case to be made for larger companies that are looking for that kind of project. Save lots of time and man hours and guys climbing up to look at DP gauges. And like Dominick said, broken bag. Oh no, we're dusting out the stack. Let's shut down our process for, 8 hours and fix it with a crew of 6 or 8 guys. All that's very expensive and all that can be avoided now. The tools are becoming very competitive and easy to implement and add to your existing control systems and very inexpensive. So if you have any questions about that, please reach out to us. It's something I'm personally really excited about. I think that's kind of one of the new frontiers of dust collection based on the AI compute, available and all these different tools. So it's really cool stuff. You can save money, you can save time, and it's a really interesting, way to solve problems out there. So, okay, a couple more questions here. Surface protection inside the baghouse, which doesn't have a chemical dosing system in the flue gas. So, Dominick, any kind of inlet flue gas could have all kinds of different chemicals in it. Is there anything we can do to protect the baghouses? What are the most common kind of scenarios where we might have to do some kind of protective coating, and how do we address that?
Yeah, so this is a little bit more of a professional opinion piece and part of it. So I think what they're getting at is should we be spray coating the interiors of the baghouses to protect them from incoming dust and gas? Now, on that subject, I would say it depends. So some people feel very strongly that that benefits the life of the baghouse, gives some extra protection. Um, the reality that you face right away is as dust comes in, the dust is abrading all of the surfaces, at least on the bottom, the dirty side of the dust collector. So any coating you spray in there, I mean, it's gonna get hit and beat up very quickly, right? So our opinion is that they're not really the greatest resource to use, and we really shouldn't spend too much time on them. If people ask us for them, you know, um, we sometimes will defer, obviously, to what the customer wants, but sometimes the customer has very specific experience with their chemicals, their process. So, of course, if we're requested to do some kind of interior coating on the baghouse, we will do it. Um, we think it's better if you have issues with corrosion and things like that, reactivity. You're better off upgrading the construction of the baghouse to some kind of stainless, or, I mean, if it's really, really reactive, you're really looking for more something like a specialty alloy or something that you need to construct at least the surface contact areas of the baghouse. So that'll be the bottom half of the baghouse. And that's really going to give you better protection. Now, if we're referring instead to injection of chemicals to or compounds into the gas stream for like absorbing catalyst reactions and things like that, that's very specialized. There are a lot of that. More commonly with baghouses, what you see is injecting things like lime, diatomaceous earth, or some other materials. Sometimes it's done to protect the bags, like a pre-coating on the bags, which is very common and absolutely we should do. Sometimes it's done upstream to absorb some chemical or some compound before it gets to the baghouse. A very common example is injecting carbon black, or I'm sorry, activated carbon into the duct as it's going to the baghouse so that it absorbs mercury. And then that can be collected easily in the baghouse because it's just more dust at that point. So those things are all fine. Those aren't really protecting the baghouse per se. And those are a lot of times separate injection systems that we would do, even maybe with pneumatic conveying to get it up to a certain spot. But yeah, I think that answers what that was about the different for managing different chemical reactions and things like that.
Very good. Okay, cool. I think we have time for maybe one or two more questions. There's one in here about dust collectors for explosive dust. Scott, if someone has what they think may be explosive or combustible dust, how do we handle that situation?
hmm Yeah, so that's a good one. We get that quite often as well. Different dust types have, different rates of combustion and things like that. So when we are looking at your overall system, we want to know that right away. There's additional fire prevention or explosion prevention accessories, we would call them, that do need to be added per OSHA or NFPA standards. Again, thinking about the safety of everybody at the plants, your dust collector. We don't want anything to explode. We want to make sure that we look at it overall. So a lot of times we'll ask you that, is the dust explosive or combustible, excuse me. And if it is, we'll ask you for a few more details on how explosive it is, essentially, how easy, it can combust, how easy would it be for a fire to start, essentially. And based off those values, we'll make a couple different recommendations as some different things that we can add to your system. Generally, it would be before it reaches your baghouse. So we'd be looking at like some sort of like explosion vents, for example, if you've heard those terms before. Uh, what else do we have? Rotary airlock that is able to withstand an explosion or something like that as well. An NRV would be something. We can look at mitigation things such as some sort of like sprinkler system or even like, infrared technology as well, to be able to detect a spark and put it out before obviously it reaches the bakehouse and goes, everywhere essentially. So that's definitely a pretty important factor when looking at your system. A lot of systems were grandfathered in, and a lot of systems that we see today have absolutely zero fire protection equipment on them. So we definitely want to make sure that we keep your guys' safety in mind. And we'll always add those on the pricing sheet, for example, with a good description as to what each item does, and then you as a customer obviously can decide what you want to do. Generally, your fire marshal or insurance policy or an insurance person will ask that you do have some sort of fire protection or explosion protection devices on your bakehouse dust collector when doing a new project. So it is something that we do see across this industry.
Yeah, two
And
points.
then,
Sorry,
yeah,
Scott, I
go
was
ahead,
just
Matt.
gonna not step on your toes, but two things you said there that were really important. One is your local regulations and your requirements may vary from what the NFPA
Mhm.
standard says. So we will always be able to quote you equipment that will allow you to be compliant with the NFPA guidelines. But those are not actually the law of the land. Wherever you're at, your fire marshal or whoever your regulatory agency is, they'll most likely use the NFPA standard as their guidelines, but they might not. For some other reason, they might have a different standard. So it is important that you communicate with whoever your local regulator is and make sure that they approve, because that's what you're actually going to be held to comply to. And the other
Yeah.
piece there is, if you're not sure, because a lot of people are like, well, I have a wood shop or I have, we're doing grinding. Is it combustible? I don't know. Which the first step in the process, if you go back to the OSHA requirements and NFPA, the first thing you're supposed to do is get a dust hazard analysis done. So you get a bucket of your dust or a little package of your dust, you send it off to the lab. And if you're not sure how to do that, you can contact us. We have a lab that we work with that makes it very easy. It's like $1,500 or something. They run all the tests and they'll tell you it's combustible, not combustible. And if it is, all of these key factors which you will need to size explosion vents and other things like the KPA, the Pmax, all these values, KST values, stuff that is required to calculate the sizing of your vents and other requirements. So if you're not sure what you got, let us know. Send us an email. We'll hook you up with the lab and they can do a DHA and then provide guidance from there. All right. Let's see. I think we'll do one more here. Let me go down the list. Um, where did it go? Okay, here we go. Looking for baghouse maintenance schedule and techniques along with testing methodology of identification of defects in the system. So I think what this is generally asking for is a maintenance schedule, and then how do you inspect a baghouse or see if you've got issues? Is there a couple like basic things that we can mention here? I think we can probably send a link to our inspection checklist. I think we already sent the maintenance schedule. What about identifications of defects? Dominick, you want to just hit real quick on leak testing or in basic visual inspection?
Yeah, actually, I was thinking, I was thinking probably the biggest thing, Scott can attest to you as well, Matt, when we do inspections, like the number one thing, it's so common, if we just keep it on our report template because it's always applicable, is verifying that the differential pressure readings are accurate. Um, Almost every single plant we go to has some problem with the differential pressure readings, where it's just part of how that system works, that those little tubes get filled with dust or the gauge gets fouled or something. So first thing we do, we have to establish if we can trust the readings or not. And if you don't have a regular PM to blow out the air lines, verify maybe every month or every 3 months that the gauge is working, like connecting another gauge that to verify. If you don't do that, we can't trust any of the differential pressure numbers you give us. And then a lot of times that's the only variable or it's the only monitoring metric we have to know how things are working. So I would say the most important thing is spend your time making sure those DP readings are accurate and collecting them. And then what you're talking about with leak testing, that's very good. You should have on hand we recommend enough powder to do two tests. So enough to do it with two different colors. That way you can have like a follow-up test after you've done some work after your initial one. But yeah, that's simple. That process is very simple. We have a guide on our website. Maybe Andy can put it in the chat below. You just go to our website under leak detection supplies and testing. It's there as well. We inject the powder upstream of the baghouse. We go in with a black light looking for holes. Most cases, the hole is obvious enough when you go from the top and look at the clean side of the dust collector with the black light. Sometimes, and this is something people usually get wrong, sometimes you have to go on the dirty side and shine the light down there because sometimes the hole is only visible from the bottom. And people might, miss that key part and say, oh, I did the test, I didn't find anything. But everybody should be familiar with how to do the test, how to inject the powder, because it really should be a regular thing. If you've only got one person that's like the expert on that, and he might not be there all the time, you really should get some other people trained to do that because it's really something you should have at hand, ready to do whenever you have a suspicion that there's a problem.
Definitely. And yeah, there's more info on our website too. If you have particular issues with your dust collector, you can find a lot of info, including how to do the leak tests, some inspection procedures, and stuff like that. So it's an hour and a half in. I think we'll cut it there with the questions, or there's a whole other list of questions that people submitted when they signed up. We'll respond via email to those questions. And I'll throw out there also, Andy and I were speaking just before we started here. We'd like to do another webinar related specifically to the smart monitoring, so emissions monitoring and all those tools that are available that we just mentioned. So in the next 1 to 2 months, we may have something specific to that. So if you're interested in that, let us know. There's a lot of great information, a lot of new interesting developments in that space. So, it's great tools. Anyways, we'll have more on that. So we will reach out. If you have any questions, I don't know if you can maybe put it up there, Andy, but info@baghouse.com goes to our whole sales team. So any questions that you have, of course, if you have a project coming up you need some help with, we'd love to help you. If you have questions about how to gather up all that info that Dominick and Scott talked about, you're not sure where to start, we're happy to help you. So just reach out and, we want to partner with you. We want to give our expertise and make it available to you. And we sure appreciate your time spending this hour and a half with us. So thanks a lot.